tyFlow Basics, the script operator explained in detail, Part 1. Enjoy. So the big question here is, how far do we take this tutorial? And at this point I have to assume that you don't know anything about scripting or tyFlow script or programming, and we'll start from that point of view as if you know nothing. And I'm not an expert, but we'll try and get us far enough along that we could possibly be dangerous and mess around in scripting. How does that sound? So the first thing we're going to look at is this block of code, which is fairly typical of like C+ and tyFlow script code. So let's start with comments. So in this is a comment line, right? And it's defined by these two forward slashes. So that means that I'm going to write a comment in my code which is non-functional code. It's just for your knowledge, and it's a good idea to write comments as you go along, because in a couple of weeks or a couple of months you're going to forget everything you've wrote. Now, I write other programs in C, so I have this habit of starting my comment with my initials, and that's basically, if anybody else works in the code later, that I know what I did and what they did, and then I give a brief description of what that code does. Now in this instance I've written code to help with this tutorial. So a comment just allows you to put some sort of text that doesn't affect the program whatsoever, and that you can type anything you want, and anything after these two lines is ignored. There is another way to do a block of comments, which is kind of do the forward slash with an asterisk, alright, and then later on you can do an asterisk followed by the forward slash, and that means any block of code in between that will be treated as one whole comment and blocked out. So that's the comment part of programming. Try to do it. Good commenting can help you understand your own code later. tyFlow has a set of like API. He has an API which is his kind of instruction set for what he allows you to do with script within tyFlow. Here's two examples of it, and we'll take a look at these in more depth in a second, and they're colored slightly differently, so anything kind of along that color line is tyFlow classes, methods, that kind of thing. And don't get caught in that. We'll talk about it in a second. As well as tyFlow methods, there's also standard C+ kind of methods and classes you can use. Now, it's not really documented in the tyFlow API information, and not everything can be used, so there is a little bit of playing around and trying to see what's supported within the script operator, and it's just a matter of kind of using the different C+ stuff that you want to try to use and see whether or not it causes an error, and then that's kind of what I did. So for example, these couple of things here aren't listed in the tyFlow API, but what I'm doing there is I'm converting this decimal number to a integer, and here I'm using a standard C+ method to convert a integer to a string. And this public part here is part of how you declare a method. A method and function are the same thing. It's just a way of organizing your code. Now variables and their values kind of go hand in hand. So here's some example of variable values, and here's some example of variables. Now, what is a variable, right? I1 is a variable, and it's basically a placeholder for data, right? And it's what data that you decide to put in it, but in this instance it's defined by the integer type. So in other words, I1 can hold whole numbers, right? Because it's been defined to be a type integer variable. And the reason we call it a variable is you can change it over time in code. So at one point, I1 could equals 1, and later on it could equals 10, or later on it could equal whatever you want it to be, as long as it's an integer, right? Now, there is also an important caveat about variable naming conventions. So I1 is a variable. I1 with different capital lettering is another variable. They are not the same. Everything about variables in programming is case sensitive. So these are all different, if you can sense my different capitalization here. So be careful how you type and enter your variable names, because it is case sensitive. So if we just go back and look here, I1 is a variable I've named called I1, and I've decided to store the number 1 in it, right? So, and then later on I've called f.2, and I'm storing a floating point in it. And with this little .2f, that's actually a way of showing you typecasting. In a way, I'm saying that because this variable is a float number, 0.2 is actually treated as a double, and the way that I'm converting it into a float is by putting the capital F after it and letting tyFlow know that I want that to be treated as a float number. And also, one thing you'll notice about my naming conventions, about how I do it, is I tend to indicate to myself what they are. So you can see the integer, I've preceded it with a small I. On the floating point variable, I've put a small f in front of it. That just, and for the string down here, I've put a small s. That just kind of lets me know throughout code what type of variable it is without having to kind of look it up. So it's just a helpful way of writing code. Now, a string, right, is a block of text, and so that's a variable that holds a block of text. So in this instance, this string would equal hello between the quotation marks, and you don't the quotation marks aren't included as part of the variable. What's between the quotation marks is the string itself, but typically when you define and use strings, you put them between the quotes to be able to define them and use them. So that's just touching on the basic variables. And if we go back to the beginning here and look at this little semicolon, right? So we got the semicolon. You have to put a semicolon at the end of each line of code. That defines the end of that line. So when we look here, here's a line of code, right, followed by a comment, but the line of code finishes off with the semicolon to say that is the end of that line. And you'll notice that every line of code I have, that's actual code and not comments, ends up being finished off with the semicolon thing to let you know, to let the compiler know that each one of those is a line of code. So let's just do a couple of actual examples. So I'm going to define an integer, right? So I'm going to define an integer, right? And I'm going to call that integer my integer, right? and I'm going to give it a value. So, and then I'm going to finish that as a line. So this line of code says create a variable called myInteger and put 0 in that variable, right? Later on in code, I could do something like my integer equals 10. So now we've changed the value from the initial 0 to a new value, and you notice that you don't need to preclude it with the variable type because it's already been defined as a variable. So that's one quick example. Now we could do another one. Okay, string. String is text, right? So we're going to define a string called my string, and we're going to have it contain hello. So that is a functional script line. We've defined a string, and we've called the string my string, and we've put hello in it. Later on, if we wanted to modify it, we could do it several ways. We could say my string equals goodbye. And now we would replace hello with goodbye. We can also add strings. So for example, my string could now equal hello plus goodbye. And that would be a valid assignment of text to a string. Alright, so we also have a thing called functions, right? And tyFlow has two of them that are, well, it has more, but the two we're going to concentrate because we're not going to worry about multi-threading at this point, because I think it's beyond the scope of this starter tutorial. But this is two functions here, right? So from here to here is one function, right? And from here to here is another function or a method. Now, without trying to turn you into a coder, a function or a method, they're the same thing depending on who you talk to as far as the wording they want to use, but it's a way of, say, organizing your code into a group of or block of code, right? Now, these two functions in tyFlow, this is the function name, right? And in this case, it's called simulation start. Now, that's a tyFlow class, or it's in his API, and basically, if you want code that you write in the script operator to be run when the simulation starts, you would put your code between these two brackets, and you would have all your code in there, and it would be run whenever the simulation starts. If you want your code to be run every time the simulation moves forward, like each step of the frame, as you go one frame at a time, you will put your code in this function, and you would put it between those two lines. And then your code that are between those curly brackets here would be executed on each and every simulation step. Up here, your code would be executed only on simulation start. Alright, this is deeper than we need to go. Public is just accessibility description, right? Or it defines accessibility to the function. The void thing here is a return type, right? So what this is saying is there is no return type for this simulation start or this simulation step. I think we don't really need to know that as basic kind of scripters. We just need to know that our code goes in here, and depending on when we want it to be run, but at least let's touch on that. So even though we're doing a quick and dirty tutorial, let's try and dig a bit deeper just to cement our knowledge. Let's delete this stuff here, and let's open tyFlow, and let's add a script operator. And when we open the scripting editor for tyFlow, this is what we see. And here's the two methods that we talked about earlier, the standard methods, the simulation start and simulation step. Now, to cement our function / method knowledge, and from now on I'm just going to call them methods. And if we want to create a custom one, we have to do it outside the scope of the built-in tyFlow one. So let's do one. Let's do public, and for tyFlow purposes everything's going to be public, and we're not going to have any return type. Oops. And we're going to call it my method, and we need the brackets to say that it's a method, and then we need the curly brackets to designate the beginning and end of a method. Now, what are we going to do inside of this method of ours? Well, for now we're just going to add a comment to tell us what it does. And in this one, it's going to print a line of text for debugging. And the text that it's going to print, now this is going to be a tyFlow API function, and its parameters are that it needs a string, which we do in the inverted commas, the double quotation marks. We enclose our string, and we're just going to say we are in our method, and we end it with the quotation marks and then the bracket, and then we need to tell it that this is the end of line of code with the semicolon. So this is a fully functional method, and to use that method we could either, I'm just going to push all this stuff down, to use it in tyFlow we could either use it in simulation start or simulation step. Well, let's see what they do. So we're now going to call this function that we made. So we're going to use my method, and that's how we call our custom function up here. So whenever this happens, simulation starts, we should print this line of text to the MaxScript listener. Let's see if we've written good code. It's green if it's good, but we need to evaluate it, and it seems like everything we wrote was okay. Otherwise you would see error messages and this would turn red. So now if we open our listener, MaxScript listener, and we'll just clear all this stuff out here, and we evaluate again, we can see that we have a line of text here that says we are in our method. Now that's only called every time the simulation starts and stops. How do we know that? And when does that happen? So this is a great debugging thing, just to print stuff to the listener. But if we open our editor, and let me rearrange this stuff a little bit here. We open our editor and we disable the flow, and then we re-enable the flow. You can see here that we got a second set of printout from here, right? Clear all, disable, enable. So you can see that when the simulation started or was initialized, this method was called. This method referred to our function up here, and all we did in it was print out a text of line. Now if we want to see how it works inside of the simulation step, if we call the same thing every time, we copy that and we put it down into the simulation step, and now we're going to call our method from the simulation step. We'll disable the one up here by putting comment marks in front. That'll treat the rest of that line as a comment and ignore what's written there. And now we'll evaluate, make sure we don't have any errors. And you can see, because we were at timeline 75, it actually wrote 75 times we were in our method. But we'll go in here, clear up this mess, and now we'll go through and step. Sometimes you got to initialize it with an evaluate to see the output, but you can see every time now we go through our timeline, every time we advance the simulation steps, we end up having some other information, tyFlow information, but we also get our printed line of code from our function, and it occurs every time that we do a simulation step. So let me put that back into 0, and let's also comment out this custom method here. And to finalize our understanding here on making methods and doing things for yourself, we're going to do another method, and this time we're going to add two numbers together, right? So in this instance it's going to return something. So it's going to return what? We're going to have it return an integer, which is a number, right? And we're going to call that method my add method, and it's going to take two parameters, right? We want to add two numbers, so we're going to add what? Two integers. We're going to call A, and we're going to call integer B, and we need the curly brackets to define the beginning and the end of that method. So here we now have a new custom method that's called my add method. It's going to take two values and it's going to return an integer. So in here we're going to say return A plus B, end of line. That's all this function's going to do, right? Return A plus B. So down here now, to call it in the simulation step, right, we're going to use my add method, and it needs two parameters, right, A and B. So we're going to say 5, 5, and remember that there was a return type this time, so, and it was type integer. So integer I added number equals that, and we'll finish it off with the end of line semicolon thing. And now let's evaluate that and make sure we haven't written some bad code. No, it passed. And now if we clear all this stuff here and we advance the timeline here, and the reason we didn't see anything printed out is because we forgot, or I forgot, to print, right, the tyFlow internal API function, right, for putting something out to the MaxScript listener, and it's limited to 100. You can only print 100 per any event thing. But anyway, we want to print what? We want to print the added number. And now we'll reevaluate, put our timeline back to 0 here, reevaluate. We don't have bad code, right? And now when we advance, you can see that it's outputting 10, which is the return number from our custom method. I hope that at least gives you enough information about methods, functions, variables, and at least maybe how to use them a little bit, and also get some insight into the print function and how it can output stuff to the MaxScript listener. Let's see what an error in this line looks like, right? So I've written something totally gibberish here. There is no such thing as my function a whatever, it's just gibberish, right? And you can see here that it now comes up with red pinkish color in this status error thing here, and it tells you where your problem is. It's going to tell you that in line 25, which you can see by our line number, and you can see it doesn't exist. So if we delete that, that'll help you and reevaluate. You can see when you type or do something wrong, it's going to let you know, and you can try and troubleshoot from there. Let's delete this script operator for a minute and add a new blank one. And open it in the editor. So this is the default state. We open a tyFlow script. Now this is example code from here to here. Alright, and remember what I said about comments? That's the 2 forward slashes is a comment line, and then I also explained to you about if you put it between this set of like a forward slash with an asterisk, and then down here an asterisk followed by a forward slash. That is a blocking out this whole section of code. But here Tyson's given you an example set of code, right? But right now it is blocked out with these comment markers that block out a whole block of code. We're going to delete that for now, and now we would be ready to create particle code. Now this simulation step threaded is beyond the scope of this tutorial. That's if you want your script to be multi-threaded, so we're not going to touch on that, right? And down here there's also a method that you can use to do stuff post simulation steps, right? I've used function and method interchangeable, and it all comes down to who you talk to and whether or not you're referencing object-oriented programming or not. But really, honestly, for the purposes of this script tutorial, either function or method will do. And if you want to do anything, just blame it on me being Australian and having bad terminology. So how do we know what we can and can't do? Well, that's a good question. That's partly why we're making a tutorial, and hopefully I'm not confusing you, but the documentation is rather lacking. But you got this API button here, and you've pressed that, you get this window pop up, and it gets updated every time Tyson changes or added something to the script operator, and that's currently what's available. Now it's kind of laid out the way you would in code, so all these forward slashes are just comment lines so that it can be included at the bottom of a script file, and it's kind of broken into sections. So rather than looking at it this way for now, I've put it into a Notepad plus file and kind of broken it up. And if we take a look here, right, Control E is a shortcut to evaluate the script, and you can see here tyFlow class properties. So this is a section of functions, methods, and tyFlow supported things you can do, and they're breaking into different areas of functionality, right? So like matrix tree stuff, simulation kind of stuff, object stuff, face stuff, binding, ray hit, terrain things you can do, any of the point classes like get access to point data and manipulate point data, mesh stuff, and just miscellaneous stuff. So it's broken into all these sections. And what does this mean if we're looking at it? All right, void is a return type. So in this case, this doesn't have a return type, but it requires a Boolean value. Now we didn't talk about Boolean, and that's just because Tyson's trying to mess me up here. But a Boolean value would be true or false, right? So bool equals true or false, and that is equivalent to 1 for true and 0 for false. So in this instance, if you want to call this set threaded function, it doesn't have any kind of return, but you need to provide it a Boolean value, in which case you would probably say you could send 1 or true to tell it to turn on, or 0 or false to turn off. So if we look here, get the simulation index, it requires an integer for the current event, and it returns an integer. And here, down here, like if you're getting the age, it requires and here's a description, right? It requires an integer, and it's going to return a float. Now, I think we better just get in there and screw everything up and play. Alright, I've set up this little test flow. It's nothing big. Here we're just birthing 2 particles on frame 0. We're going to give it a 3D shape, in this case a cube. This is for later on, and we'll see how we can manipulate data in a custom float or any other type of custom properties file. This is just a script I've written for me, both are disabled. This is absolutely default script, as if I just dropped it in there. Display operator so we can see the geometry, and just 2 custom data displays, and really they're just set to look at 2 different particle IDs. So down here I can separate them on individual lines instead of having them right over the top of each other. So we can see right here that we've got 2 particles. Well, we can only see one of them, but by the IDs we can see that there are 2 particles there, one with ID 0 and one with ID 1. We also have a box here, and that's so we can briefly touch on how to make that accessible from within the script operator. Let's go in and look at this default script. So we open the script, and I said earlier that this is a sample. This is a sample script. It's just been commented out. So I haven't edited anything in here, so let's just delete these comment lines that block it out. Alright, so we delete those, and I haven't written anything. This is all from Tyson from here. So basically what we're going to do, and we haven't touched loops, but I will in a second, but he's going to loop through all the particles, he's going to get their simulation index, and he's going to modify the position. So if we run that and see what happens, evaluate, and if we look over here we can see our box moved, but we're still on 0 timeline down the bottom left here, and that's got to do with the way this is set up. But right here we can see that we've got a script and that it has affected our particles in the viewport. Let's mess with this standard sample that we've got here. In this standard example that was given, we didn't actually see the movement happen. It happened as soon as we evaluated. Why was that? Because there was a test here, and it was against the event age, and it was with the event age being 0, which is at the very beginning. Now, in this instance, particle event age and frame number is going to end up being the same because of when they're born. So technically, if we wanted to see our particle move, then all we would have to do is come in here and change the event age test to say 2. And now when we do evaluate, the particle is going to move back to its birth position because this hasn't happened yet, alright, because the conditions haven't met. Now, two things that we didn't discuss earlier were loops or condition test. I'll cover them before the end of this tutorial. So let's see what happens now when we go through the timeline. We see as soon as we get to 2, it moved. And basically, if we go through this script, we got a for loop here that steps through all the particles in the event. So even if there was 50, we're keeping it small so we can look at the data, right? Even if there was 50, this part of the loop here, which is from there to here, right? So everything in between there would happen in this loop for the number of particles, right? Then we get the simulation index. We get the event age of each particle, and we test it against this. And if this is true, then we do what's between these curly brackets. And for example, if we wanted to change the position to be more and say do 20 and now evaluate, it's going to move even higher because we said now move 20, right? And let's see if we can learn a little bit by manipulating this and cover some of all of these things in this script. Let's take a look at this for loop, right? Remember, I'm treating it as if you don't know anything about programming. So, a for loop. So, it goes like this, for, and then you have the brackets because it's a function, right? Method, and everything in between the curly brackets will be done in this loop, right? So that's the basics of a for loop. Now it takes 3 parameters, right? So if we do a little curly thing and we have 3 parameters like this, right? In a for loop, it needs to know what to start from, right? What test condition to be met for it to happen, and how to increment. So in this first one over here, right, he says for integer I equals 0. So that is, so you know, this is how the loop starts, right? So here we have a start, a test, and an increment, right? So we're going to start it. I'm not going to copy all this. We're going to start it at 0, test it against the particle count, and then each time we're going to increment the I value, right? And for each time we do that, we're going to execute the code between the brackets. So if I hide this for a minute and delete that, and we look here, we say for an integer equals 0. So we're initializing I to 0, and then we're going to test the value that's in I against the particle count. Now in our flow, that would currently be 0 and 1 because we have 2 particles. And until the condition is met that we've met the count of particles in the flow, we're going to keep doing this loop and increment the value by 1. Now I plus plus, right, means increment by 1. I minus minus would mean decrease by 1. Now we don't have debugging here, capabilities the same as you would be in a Visual C++ compiler, So you have to do some debugging by using the print operator. But just be careful how you write the code. If you don't get too complex, you don't need to debug it. So that's the for loop. So let's say right now we know we have two particles, 0 and 1, and it's stepping through those. What do you think would happen if I put this back here and change this to say 1? Alright, and now we evaluate and we step forward, and you can see only one of our particles moved, and that is because we're not stepping through every particle, we're only doing particle 1, and you can see that right here, right, that the ideal one is the one that moved because we started at 1 not 0, so we essentially skipped 0. So you can see here how you don't have to step through every single particle. You could do some random stuff here. Now, how did this I value end up determining which particle to move or not move? That's because here I is used again as a reference for getting the simulation index ID, right? So we're getting that value, so we're getting the simulation index from particle 1 and putting it into this temporary storage holder. And then we're using that temporary storage holder all throughout the script here to manipulate the particles. I hope you get that and I didn't confuse you. But let's play with a few things to see if we can lock this in. So we're back with a slightly different setup here, but all that's different is I've added some more display data operators, and you can see the particle IDs that they're referring to, and that's really just so I can do a line offset on each particle ID so we can see that the line's separated. And apart from that, everything else is the same. So if we go in here and now birth 8 particles instead of 2, and you can see here it starts to count down here at the bottom before it goes off the screen. And now we evaluate our script. Everything is still good even though we've got 8 particles. Don't forget we're still starting from particle 1 and not particle 0, so when we scroll through on frame 2 we can see that particle 0 still stays where it is, but the rest of the particles from 1 to 7 move. Now we can get more creative than that as well. For example, we could change this to plus equal 2 and evaluate, right? And now when we scroll forward, you can see that with our 8 particles, we've only moved every second one, and all the other ones, second ones, have stayed. Now why is that? That is because we changed the step size here, right? This was the increment size, right? And instead of just incrementing by 1, now we're incrementing by 2, and we could play with that and change it to 4, whatever, and it would mean that everything in here would only occur every second time, so to speak, depending on this increment. So with that in mind, we've covered a little bit of the for loop. Now with this I plus plus, you got to think of it that way. This is really the equivalent of I equals I plus 1. Alright, so the way I write this here, I plus equals 2, essentially translates into I equals I plus 2. So you can kind of maybe try to visualize that a bit better. Let's say we don't care about event age, right? So let's just delete this stuff here and hide that for a minute. Removing what we didn't want to reference, the event age, so we're going to delete this, which is going to mess up our test here because there's no event age. So if I evaluate that now, we're going to get a red, right? And what we're going to do instead is use a built-in tyFlow thing, which is F for frame. Alright, so if F is greater than 1, alright, now you can see how I'm manipulating the if test. So if the frame number is greater than 1, do what's in here. So let's just see first of all if that evaluates. And it evaluated. So if we go back here, clear this stuff out of here, clear all, and we evaluate again, and then we go forward. As soon as we get more than 1, you can see the same thing happen, but now it was based on if frame is greater than 1. Now nothing seems to happen more after that, even though we are technically still going back into this if test, because every frame after 1 meets this test of if it's greater than 1. So the reason nothing else happens here is because we've fixed the manipulation, right? We're only saying position Z equals 20. That can only happen once. But what if we did something like, alright, position Z is now going to equal the previous position Z plus 20. And maybe we change that to 10 so they don't shoot off the screen. And now we evaluate that. Alright. And you can see they did shoot off the screen, but if I go back here to the beginning and clear all of this, and now we step through it, as soon as we get past 1, they start moving, and then move every single frame, and every second particle is going to move. So this tutorial is going to take more than one. I think it's going to need at least 2 or 3 parts to keep going with this. But I'll just go over this if statement and how that works. If statements. Alright. If something between the brackets is true or false or whatever, do something between the curly brackets, lines of code here, right? So a test condition. So a test condition could be if I equals 1. That would be one example of a test condition. Another example of a test condition would be if I is greater than 1, right? Or if I is smaller than 5. We can also do complex testing. So we could do if I is greater than 1 or I is smaller than 5. Do your code. Alright, so this double line, which is the symbol underneath your back button and above your backslash, that's the equivalent of an OR statement. And there's also, you could also use an AND statement, which is kind of like terrible AND symbol here, but that would be AND. So OR means either. If either condition is true, do the test. AND means if both conditions are true, you meet the test. So that's kind of the if statement. There's a variation of the if statement, and it could be like if I equals 1, do something between the curly brackets, but you can add an else, alright, and then do something between those curly brackets, right? And what that means there is if this test condition isn't met, then do whatever code you put in the else thing, and I ran out of space at the bottom here. But so that kind of covers nearly everything about an if statement, at least the basics. Just to show you that in action, let's use the AND operator here. So the double AND, alright, and frame is smaller than 3. Do what's in between the curly brackets. Let's evaluate that. Everything looks good. Let's do our timeline down here and see what happens. And you could see once we got past 3, it stopped working and didn't move as far as before. Like if we say 6 now, evaluate that, you can see it continued to move, and then we'll do until frame 6 and stop. So I hope that gives a little bit of insight into the for and if statements, and I think we probably got to leave it there for now. It's definitely going to be a second tutorial, and we'll take it further. I'm going to leave part A on this note. This is a little sample file I created for myself, and if we watch the example, you'll see that our sphere, which was Verino fractured, breaks up after hitting the pin, and after it starts to break up, it starts to come towards the ground, and then it actually rebuilds itself back to the way it was before. Now, this isn't any kind of morphing, this is scripting in action. And my script for this particular event goes like this. It's fairly basic, and it just can give you an idea of what can be done before we move on to part 2 and maybe part 3. But this is my simple script here, and all I'm doing there is testing for frame 2. Once we're at frame 2, for each particle in the flow, go and get its custom matrix data from a file that I saved up here at birth, right? Get that data and store it into a temporary placeholder, and then once we have that data, manipulate it by taking 90 units off the distance so that the distance is at the floor, and then saving that data back to another custom properties file that I called position def. So I'm essentially offsetting my original position so that when it rebuilds, it's actually rebuilding the same particle at a different location. So that's just to give you some motivation to play around. I'll just run the timeline one more time, and we'll see you in the next one.